Science for Social Good program, and welcome to this 2025 AI Hackathon. We have 11 teams presenting. Each team will have 10 minutes for all the presenters. So with that, good luck to everyone, and I'll let the doctor start to manage the key presentation.
And invest first. And that's why we chose this problem to help the city use its housing funds wisely and protect neighborhoods most at risk. Where the green means it's for low risk and the red means it's at very high risk. The higher the IPS, the more attention that track needs. And we also trained a small AI model to show which area needs more.
Most strongly influence housing distress. Then we normalized all those features, things like rent burden, minority share, and income gap. So things like rent burden, minority share, and income gap. So every neighborhood could be compared on a fair scale and of affordability pressure. Finally, we built a suggestion-based framework that recommends specific tracks for investment or subsidy renewal. In short, the model doesn't just find problems, it gives city a clear data and direction on where to. So we have way more to go with this part, and it's gonna need more data from all the city neighborhoods. On to beauty for the performance results.
It explained almost 87% of the variation in housing stress across neighborhood, a very strong predictive signal. So the results were clear: the affordability burden, orange and then red. For example, where to the orange and then red. For example, where to the red one means very high, which means the red one means where to implement the subsidy and all those things, affordability and for household and neighborhood. At the top right, this is the color grid or the heat map, which validates the relationship between those rent burden, and the blue boxes shows where one improves as the other worsen. So our model isn't just spitting out numbers, learning from and validating the lived realities of Jacksonville neighborhoods. From these results, we can draw some important conclusion and policy direction. First, housing stress is key. By using this framework, Jacksonville can take informed proactive action, protecting affordable homes today and ensuring a more stable and inclusive housing future for tomorrow. Thank you.
Now we'll have 5 minutes and questions from our judges.
I was curious on the explain just a little bit about what's behind them.
What's behind the economic vulnerability? So the affordability stress is where in Jacksonville, if you go to North Jacksonville, most risk is if all those things happen, then the preservation risk is gonna go up. It's gonna mean the area is not sustainable for them. They had to move to a different area, which potentially means losing their jobs, which they are doing in the particular area.
Thank you.
So, based on those factors, how did you determine the weightings, and what did you use to normalize? What approach did you use to normalize for your score?
What approach did you use to?
You said you normalized the data.
Mm-hmm.
So how did you normalize the data for your weightings?
Because we did not.
What approach did you use to normalize?
We used random forest method to run the data on all the 25 cities which we got.
Okay, but you normalized it, right, to create your score?
Mm-hmm. Yes.
So what approach did you use to normalize?
The IPS score?
Yes.
That's taking in concept of the affordability index plus the median income and this.
Yeah. How do you QA and make sure that the results coming back aren't
because
hallucinations
the random forest model knows, because we tagged the GeoID with the tract from the US federal website, and we tagged each shape to the neighborhood, and we rated the neighborhood with an IPS score. So it's gonna show from a 0 to 1. It rates the IPS score first, and then it takes what is the equity impact in that area. So it's not 100% accurate. It's gonna be accurate when we train it with more neighborhoods in the coming days.
Hey, well done. Well done. Quick question for you on that previous slide around exploring additional data sources. You talked about the migration sources of data that, in this day and age, obviously in Florida and Jacksonville, it's broader than just one city. So, what do you think you should do to expand on that? Like, if you had time, what do you think you would do that additional data source?
I would definitely have the data sets. We can use that. And the next is IRS migration data, which gives the tax which people pay to each state, and we'll know what their income is, and we can rate them, and we can determine how their income is going to affect the housing prices here.
Great. Nice job. Thank you.
Thank you.
Great presentation. Better, program to be updated in real time.
As of now, I'm not sure what all the policies the city has, and what policies can the city influence in the coming days, or is there any way we could, and where to ask for the funds, and how to ask, and whom to approach. Like we can just talk about it within ourselves, but there should
Add it into this model to make it more effective.
So currently I'm working on a college project which is based on food recommendation, which
Thank you.
All right, our next team pressure.
Hello everyone, I'm John Butoto and I'm a member of Dojo Board. Instability that is caused by rising rents, expiring subsidies, and income disparities. And so the government lacks an established data infrastructure to help and be able to apply the knowledge that we have to create innovations in this sector. So in the solution that we came up with, what we did establish a baseline feature that we can use to tell us about the results that we had across different cities and the percentage accuracy that we achieved was 77.8%. And from this solution overall, we'll see that we can be able to use it to be able to tell the areas that are mostly affected by risk and which factors exactly that affect that influence the displacement risks. Yes. So as I said before, we collected data from 6 different data sources. 6 different folders, but the main data sources were census housing data. And we had data and from there we interpreted that, and we were able to create one comprehensive data source. And so the overall methodology that we used was that to train another model that will be able to tell us which features exactly influence the displacement risk that we see. And we had a total of 98 features that we used to train
undergo displacement, and we can estimate what percent of total neighborhoods that we have in a particular city would go displacement. But also from the map, we can see the distribution of these neighborhoods that are unlikely to undergo displacement, and maybe get some other similar characteristics in terms of geospatial characteristics. And we can look further into that because we might have data for like sensors and all that, but we don't have the geo characteristics similarities between these cities. So by attaining the number of high-risk areas in a particular city, we took them and analyzed for all the peer cities. With Jacksonville included, so as we can see the performance and how many or what percent of neighborhoods in the city are likely to undergo displacement. As we can see from the rankings, Jacksonville is on the 5th position, and with the low percent, it means that neighborhoods in Jacksonville are less likely to undergo displacement as compared to other cities, as you can see where Fort Worth is the last one with 6%. That means the low population of neighborhoods in Fort Worth, then a larger percent in that particular city has neighborhoods that are likely to undergo displacement.
The ability to correctly identify high-risk areas by 90%. So the model overall can perform on 78% and 90% on identify all the vulnerable tracts. So also the clustering, we use the 4 features to create those 3 clustering groups. The clustering seal out factor was 0.62%, so that we can have median household income and housing builds. Those are which are old, so they have risk of lead paint risk. Also, low-income renters area. We can provide one or two recommendations that can solve this problem, which is generally is to tackle all these features, but one or two that we can.
I can see that in the policy recommendation, you have some recommendation. Did you actually use that as your input to your model?
No. So the policy recommendation come from the features that greatly contribute to the displacement risk in the model. So the model gives us the most important features that generate if the displacement risk is high or low. So from tackling these features using this recommendation, we can be able to sort out the displacement risk in the
I think my question is that general business knowledge you applied, or actually you have,
No. Okay. These are just recommendations based on the features.
So because we have a model, right? So if we create like a synthetic data, we can input that like using all the features. So say we
learned from exploring the feature sets that went into the model.
Yeah. So we had 98 features, and from we had 98 features, and from feature importance and feature selection, 15 of the features were reduced due to high correlation. They had correlation of 0.95 and above, which highly correlated to other features, so we had to remove them. So ultimately we had 83 features, and after the model training, measuring the feature importance of each feature, these were the ones that contributed more. So they had more feature importance than the other ones.
And were any of those engineered features, or were these straight provided from the data files you guys received?
Yeah, so only one feature which we used in the second model was engineered. That was the one of files, and then we reduced the features using this technique. So using correlation, we reduced features until we had the final 83, which is this.
Yeah.
We're the third team presenting, and it just so happens we're solving the third problem. So our product is called Block Quote. So I want to start with some context. Housing alone, and then 7 million of home shortage. There are 7 million home shortage for low-income families. Even with these numbers, the population rate is increasing with the urban population, at least. And there are investors that are willing to invest in land, in property, and also even cities that are willing to invest. However, the main problem with this is where to invest and how we can use that money. Investors spend a lot to know who you're investing into, what is the community, and we're basically trying to see assess the neighborhood, what type of neighborhoods are they investing in, what type of demographic being invested in. So you're seeing the impact of the investment plan on actual people through these agents. So basically, they give you a response to how they view this investment plan. Do they view it favorably? What do they like about it? What do they dislike about it? Would they like to move to this community, and why would they like to move, or why would they not like to move? So basically, we show a diverse of personas based on different people, show what they value, what they basically helps them with the initial research. It gauges the sentiment of the community, and it also helps them refine their plan early on. So that they can spend and allocate the majority of their resources on actually helping the community.
Essentially pivoted that data from a long format into a wide format. We were given a whole bunch of data in different files. We combined all of that data into a single file as well. And on the right-hand side, you can see the architecture we used. It was every row is a different tract ID, which is essentially a different location in Jacksonville. And the columns were also the features and labels that we are looking for. Okay, and the data we were looking at was income, race, gender. Solutions was more like headed towards a machine learning role. Well, we wanted to take a more like creative route inside of that, and instead of finding these solutions, we created digital agents to represent these personas. These personas are the people and the citizens that are living in Jacksonville in your demographics. Then we use the data to give these personas actual characteristics and living situations from the data. And all of this was powered behind the scenes with GPT-5's API key. All right, and we'll go ahead and move on to the demo now. So, just a quick one. This is the dashboard for Blockquote here. And you can see you can create a new session if you'd like. And once you create a new session, you just have to select the city. We didn't have time to implement the data for other cities, so we only have 5 features, any amenities you're looking at, features of the housing plan, any things that are close by that you think that residents should know about. And this is really important, the census tracts that you are targeting, the demographics you want is this housing plan, census tracts are being given to the LLM, and the LLM is deciding, looking at the data that was in the CSV file, deciding how can we create personas that is representative and accurate to the people living there, the target demographics, okay? And we decided we want to create 5 of them, so very soon we'll see these 5 personas. And you can see Vanessa Hart, Marcus Jefferson, based on each demographic group, okay? So you can see their gender, race, ethnicity, education, marital status, and even age group. You're looking for a pattern, a story behind these decisions. On the left-hand side, you can see a scenario agent, and you can go ahead and chat with it. Get an overall idea, why were these agents making their decisions? Why were these personas deciding to not move or move into our housing plan? On the right-hand side, you can also see more specifics on every single agent, or every persona, and chat with them individually as well. All right. Now, finally, if you'd like, you can save the data in a nice little PDF format that essentially has all the data that was on the dashboard as well. So, going back to the results, Talia will handle this.
Okay, so what exactly are we hoping to accomplish with this project? We really want to help the investors identify the weaknesses within their plans. for the demographic that they're targeting, for the community that they want to invest in, how are their people going to react to this plan? And since the agents are going to tell the investors what they like, what they dislike, and even chat with them, the investors can come up with a more comprehensive plan that is more equitable and sustainable for the community that they're investing in. And this kind of gives a more humanized outlook on the data, since we're not just, we were given a huge set of data, but they want to pursue their research. And this will help them allocate more money into actually fine-tuning their project and actual research direction, as opposed to gauging the scope.
Go ahead and implement that data so we can go ahead and compare and contrast with these other cities. How does our model work against those compared to Jacksonville? Another one that's even more important is to enrich the data. If you want the personas to make the most accurate choices, the most realistic choices, we need to give them more data. For example, one noteworthy one is crime rates. We couldn't find any crime rate data in the census tract level, so we didn't have time to implement that, but that's definitely a future goal. And overall, we plan to partner with planners and developers so they can use this to make their research quicker and less costly. The end. Thank you.
The problem is you don't know how much data actually it has worked. Forget about the generating part. I'm talking about, let's say you have a lot of data, you have certain number of rows, you have certain sort of data, what sort of reasoning it has done to come up with. Because, especially if you use that as a prompt or context, it's a huge thing. So what sort of things you have done on that front?
Sure. And if you'd like, you can review that to double check if the reasoning was on par with what you'd expect. But what we also implemented is, you were talking about the hallucinations, if I'm right. If you calculated the weights it needed to make it a representative model. We gave the weights along with the data just for that census tract to the LLM, and it created these personas based on that.
Okay, so let me rephrase my question. Generative text, have you thought of that?
Analytics, like creating a machine learning model that will determine.
Yes, because LLM is not particularly suitable in your use case, what you are trying to do for the analysis part.
Answered this a minute ago, but what can you do to ensure the data accuracy and prevent neighborhood insecurity, AMI, 30% lower AMI, those types might be useful for this AI for developers, especially if you're focused. I think this could also be used, in my opinion, for renters and neighborhood and community biases, or prevent those biases from taking over a model when you add crime rate or you add something else to the model.
So, to better understand, you're saying, once we have so much data, how do we make sure that the LLM doesn't focus too much on one specific aspect?
Absolutely.
Yes.
So to prevent a developer, not prevent, but to lead a developer one way or the other. Don't want it to necessarily
catch edge cases. Am I going in the completely wrong direction with this housing implementation plan? And if it is, you're going to see massive amounts of the personas saying, no, we don't want to move here. And that's going to help.
And the problem case that we decided to target was problem case 2, developing a housing affordability index and creating an AI tool that be able to figure out which neighborhoods in Jacksonville are most burdened and figure out, based off the characteristics in that data, what changes we have to implement to improve that index percentage, and be able to compare our index scores with other index scores to see if we're aligned correctly or if our model was making up numbers. Yeah, I'm going to pass it off to Marion so he can explain how we did that.
The city of Jacksonville, we started to focus on Jacksonville, so we figured we might get, we want to have an index designed for the city council. If you look and here, you see we have very strong correlations with our target variable, which I'll get to on the next slide. So we decided to use an ensemble model, so it is easy to pull out the relationships that were learned, and that way government officials will be able to pinpoint exactly what is influencing affordability. 2 reasons. One, by training based off of an existing index, it gives our index a baseline level of accuracy, or it gives our index parity with an existing one, which allows for council members, although we are only looking at Jacksonville data, they can take our index score and we are able to convert it and about 84% of the relationships within the data that were influencing housing affordability.
I'm Tony, and as you can see here, and this gives us an overarching view of our score. And to explain more about our Horizon score, we kind of wanted to model it with the FICO score, and 0 being the worst and 1,000 being the best. And this is the average of all the zip codes in Jacksonville that culminate to our affordability index score. Now, if we want to zoom in, let's say 32256, we can see here that it is a fair score, and we have the positive and negative factor view this data to better interpret it.
So, looking at this zip code here, if we want to observe the positive factors influencing our score, we have the, and then on the negative side, it's the inverse. For the weight, every increase in our
suggestions on based off of the weights and what's wrong, what's good. It can give you suggestions on what you can do in that neighborhood to help affordable housing. Okay, and while he's typing this in, we took about 40 PDF documents all around the US, and that's what we're basing our policy decisions off of.
Yeah, so now we're gonna query it of, let's say I'm a city council member and I want to inquire, hey, why is my score fair? How can I make it better? Well, we can inquire and make data-driven decisions with that RAG model that are in explained, validated data, so you're not just hallucinating. And yeah, that is our full demo here. I'll go back to our PowerPoint. Have a load for a second there.
So train our models to take our data and run the representations to match the performance, per se, of their index. That way you can have the comparable scores, and it gave us a more reliable target. Originally, we tried to use features from within the data set as our features from Jacksonville that can be combined together to make their similar predictions.
Thank you. And then one more real quick, the 50 points right there. Can you talk?
And then we display the 5 most influential characteristics. So here, this one added 50 points onto the score, this one added 44 points onto the score. And then the other score, and this is the actual value of the metric. And then this you can interpret as being the power, the level of influence this metric has on the score.
Thank you.
Your weighting you are getting from regression model, right?
Yes.
Okay, so now
housing rent going up, and this is pushing residents into more cost burden situations. And once affordability is lost, people will tend to move away. And we do realize that city leaders are trying to prevent displacement. So resources are limited, and we realize that the investments need to be targeted properly in order to decrease displacement. And that means rising and socioeconomic indicators from the data sets provided to us at the census tract level. We were provided all the geo-IDs, and so we used that as a universal key, since all the other variables and all the other data sets were unique to those data sets. So we worked with all 123 variables provided, for Jacksonville, and then we
have kind of a familiar idea about what we're going to do. So as a first step, what we did was preparing the data set. So for that, we merged.
One of the first approach that we did is we considered the top 5 cities and then compared with the Jacksonville data city as well, like the patterns and what are the areas that we need. We focused on we zoomed and deep dived into each of the cities, like the 5 cities that we consider are Miami, Orlando, Memphis and all, and then we moved and started analyzing the data and the patterns of the variables and then compared with the Jacksonville. The results turned out to be surprising, and that's when so one of the results that we found is the variable of the lead risk of the lead risk place is ranked first, or the priority. And then followed by the snap share and render successive cost rate. So these are all the ranking of the variables that affect that we assume is affecting Jacksonville's current affordable sustainable.
So this is Team City Scale. I'll turn it over to them.
Thank you so much. My name is Thomas Marconi.
Hi.
Data set, or more available information so people can make data-driven decisions. So our solution, we generated a PCA-based housing affordability and risk index analysis across all 25 cities. So the main features of this, so we have a heat map dashboard, a set of filters that actually let you filter the different tracks by whatever you're looking at, whether you want to see which track, policymakers, real estate planners, and nonprofits. And we want to be able to use these data to drive actionable insights to really help the people. We don't just want this to be a project that we make over a weekend. We wanted to actually be able to change the cities that we live in. Next slide, please. This is a quick screenshot. We're going to get more into this towards the end, and we'll have a demo, but I just wanted to include this to have it there. So we also included, so the entire feature set is 178, and I'll get into our methodology, but we turned that down to around 40 data to correlate with until afterwards we found a data set of evictions for particular tracks, and we sort of correlated to see how accurate we were. Entire data set, so it's across all 25 cities. And then we apply that PCA. So first we label all of the PCs that are generated by that. We label all of the PCs that are generated by that. We standardize them using a z-score. Entire data set. So you can see not just how it affects your city, but also compares to other cities. So pass this over to Andrew.
So here we're looking at our performance results, and in this we compared our track level risk scores with Eviction Lab's eviction rates. So we classified it into low, moderate, and high risk buckets, and then analyzed via confusion matrix. And then some of the big challenges we faced were, for one, lack of domain knowledge. So pretty much none of us had any experience using unsupervised learning. So the mentors and SMEs definitely helped us out working on those and giving us some ideas. And then the feature set was definitely too complex to start. There was such a big list that it was really getting confused with what it was doing. So we definitely trimmed that down to chatbot in the early stages was having quite a few problems, especially with the amount of data it was given to try to process it. So when we reduced the feature set, that definitely helped it out. And then we'll move on.
Interface in the top left to select the cities. From here, what are we looking at? You have the entire city here split up. Higher numbers are bad, so red is closer to 100. Independently weight ones more or less. So, for example, I rated this one as a 2 for economic hardship. So it explains it right there. Higher weight equals more importance to tracks with overall score. And then just here, we also included all of the factors that that are part of the data set, just again for visibility, so that you're not just looking at one random score, you can actually see what is affecting each of these tracts. Anything else, guys, for the demo? Oh yes, and then the chatbot. So, like I mentioned, natural language and risk score. So we're actually just passing in, it's very naive, but we're passing in essentially what's in the right side of the app, and then it's generating something. But we want to go back to, and so it gives you the ability to see policy decisions and stuff. So we're going to go back to this for our last slide. Okay.
Yeah, so when it comes to our applications, if we just had more time, we could pretty much build a new team to get new data. So pretty much we don't know what exactly our data is coming from. So we wanted to, if we have more time, build a new team with the city to survey around the city, which pretty much to give the policymakers better understanding. Sorry.
Thank you. So the PC1 describes a greater amount of the variance in the data. So to our understanding, that was able to.
But that does not say only one importance of the input. Just wondering.
Yeah, good. That's a good question. Basically, it was like an averaging of the different scores for the different weights that the people are associating with them based on the variance.
But then why I will use PC? I will just take that input and then I will just one regression and I will take overall economic health. Sorry. And what I'm saying then, like if you can map one PCA with one input variable,
we try to aggregate all of those, in some way.
Your input allows for adjustment of the weights.
Yes.
Why would you allow an end user or someone else to?
If you're actually wanting to look at the data and interact with it, okay, so what if we made the urban density weight a lot less? How would that actually influence things? Okay, so we've implemented this policy. Now we have new scores for the different areas. So it was kind of the idea of like what would be the impacts of the policies that we would implement?
Yeah. We got one extra.
Looks like we're pulling an audience from outside. All right, this team is called Homesite AI.
Good afternoon, everyone. My name is Rosmaria, and my teammates are Kushal and Tejaswi, and we are Team Homesite AI. So over the past 2 days, we have built a comprehensive data-driven tool that analyzes housing affordability across 25 US cities with a special focus on Jacksonville. So our project focuses on housing and all. And in the future, this will lead to tough choices like displacement and loss of community. Now, most housing data only shows the city average, housing quality and availability. And all these are key part of true affordability, and our motivation is simple. So that is to help these communities by finding which neighborhoods need more support and use the data-driven insights to make the smarter policy decisions, and finally create a scalable tool any US city can use. So we use three main federal. When we think about housing affordability, it is easy to just look at rent or mortgage payments. But that's like only one part of the story. Real affordability is about how all the pieces fit together. What people earn, what they spend, where they live, and the quality of that housing. To better understand this, we broke affordability down into 5 key areas. These dimensions guide our data and help us see which helped us shape how we approach measuring and modeling housing affordability in a more data-driven way. First, we looked at how much of the people's income goes towards housing, whether if it is someone spending more than 30% of their income on housing, and that will be considered as a burden. And if it is like more than 40%, that means it's like a really pretty bad. They are in a really pretty bad situation. Next, we look at income compared to housing costs. Basically, are people earning enough to afford where they live? And next is like the housing, whether it's affordable if you have to whether we need to drive for a long way to reach our workplaces or not. And finally, the affordable housing availability. It's about the subsidies that's about to expire. Like if it's about to expire, they can't afford it anymore in the future. Now I'm handing over to my...
So this is the solution overview we have used. By using the above 5 components, we have created the affordability index. Before combining the 5 main components, we need to give the weighting for each component. So we have used the PCA for giving the weights. But this PCA is doing by using the variance of each component, and then after by using this affordability index, we have compared the track level and the city level comparison within the track and the city, and then after we have done the dashboard. The variance analysis means based on PCA analysis we have done the variance. Means this is the over 100% based on 100% explained. Like we have for the 5 main components, we have the first component having a 32% and the second component having a 21% of the variance, and the third component having we have dividing into 100% into different categories. And based on this variance, we have calculated the weight of the each component. Like we have seen almost all of the components having an equal weight between the range of an 18 to 21% based on the variance. By this we can say that not only a housing cost or the rent value will not say what is the affordability of the price. We need to use the other things to calculate the affordability. And for this validation purpose, we have used the cross correlation analysis. This is the cross correlation analysis we have used. We have got the maximum cross correlation between it is the 0.4 which is between the housing quality and the cost burden. By this we can say that most are there is no issue of the multi-collinearity, and most of them are not equal to, means not nearby 1, it is nearby negative values and nearby 0. Means by this we can say that these are not collinear to each other. And I am passing the mic to Tejaswini to show the dashboard.
Yeah, next will be the dashboard which we built. So this is the dashboard data. So
City has most risk factor related to the affordability index. So Louisville is the best city as per our analysis, and Miami is the most vulnerable city when we are seeing the affordability index. So coming here, we are showing all the affordability indexes for all those cities here, and we are providing the download. Housing tracks they have high risk. So all these things they can see here. We are giving some option to download as file. We are giving some option to download as files, so that they can in future they can use them for their analytics or some other type of work. And similar type, like here we are providing the index store distributions, how this index, we are giving tract level data and city level data, so that the people can download it. The state of charts personnel can download all those reports for their future use. And when we come to the tract level analysis, so here we are giving a drop down here, Jackson, where people can select the city, and here we are showing that specific city. By default it's Jacksonville for now. So here we are showing average index and how many tracts are at risk in Jacksonville and all those things here. And this is the visualizations, like here we are showing how those photos, we provided all the Jacksonville photos here and integrated with Tableau with the maps, where we are showing all those things.
Thank you. Could you go to slide 9 real quick? I think I probably have the similar questions to the last presentation, but I think it was slide 9.
Okay.
But I'm curious, as you bring it up, is how you're mapping the components to your labels here. How you come up with those labels for each of the components. If you could just walk us through that real quick.
So okay, so from the data sets, we came up with these 5 groups, like cost burden, income, house.
Oh yeah. Yeah. So, did you guys keep your hands? So he hired elsewhere, or that from where he was. So he hired elsewhere, or that from where he was reaching the 5 circles down, He asked 5 to figure it out. Actually, I think that back 6 or 7 stage. That was like 5 circles. And, we've been working with 5 circles for 10 years. And we have been cost cut and rationalized, pushed the envelope, and focused on response time and ability realized that we need a big cost. We just started with relative to the public study and the operation time, right? Operations and as it was easy to so it was easy to reach pilots fast. That was we have completely reversed that technology that's been in excess of 150 million on AWS and we've migrated to
Okay, so we'll jump back in. This is mainframe to Main Street team.
Sorry for the technical difficulties the first time. So we did a project on Spectre, which is a model to predict housing displacement before families all disappear. I am Jeremy Miley. I go to UNF. I'm a computer science student.
I'm Olivia Chrisley. I'm also a computer science student at UNF.
Which areas inside Jacksonville have the highest housing displacement risk? Now, why do we even bother choosing this goal? Well, for starters, we have a little experience with machine. Things just happen. Now, who's impacted? Mainly renters, low-income households, children, schools, and entire communities.
All right, so for our solution, we wanted to look at what factors show that displacement is happening and what
opportunity to compare. But one thing that we could do to take this further, if we have more resources, is we can add more data, because I believe a group similar mentioned this, so we just had to kind of just blow it into the wind. Now, what sponsors, let's say, could we do? I would say talking to, for example, the staff here. For one, people with connections to people who make the policies, or who has more maybe eviction data, or just more in-depth data, because there was a lot of data that's kind of closed off and you can only get through connections. Now, some of the limitations of Spectre, we're limited to only federally assisted housing data, and we also have to rely on historical data, because one thing about the government, they take a long time to process data, then submit it to the public, and it's a lot of red tape for us. Ooh, it wasn't supposed to end, but sorry about that. Yeah, and we say we want to do real-time data integration so that let's say maybe every couple months or so, we can maybe get at least a small snippet of data added to Spectre, and then Spectre can more easily calculate and predict when housing displacement is going to happen, so that cities will have more of a fighting chance. There will be more morale inside communities, and it will just be overall happier for communities, because
told that if we participate, we would get credit for our final project, and this was the closest thing to what we were covering in class, which is just regression methods. So our approach was a little bit less ambitious, I think, than some of the other participants, but this is what we came up with. Most of our time was spent actually just kind of arranging the data set. We were given I think it was like 27 files of our zip code level, and we were asking the document to go to the track level, so that's the only real data set that we ended up working with. So what we ended up doing is basically implicated a couple of percentages, but essentially what we ended up with is we took the total houses and then say like house for category X, like how many are on SNAP, how many have problems. Problems is sort of broadly defined. I think it was something like disrepair or number of people that were like below a certain income level. overcrowded and vacancy percentages and things like that. And we ended up getting this data set of percentages, so everything was roughly at the same. So there was a USDA and then there was a separate one that also kind of measured the same thing. So we weren't sure if that should overlap or anything. So we kind of left them both then. I should note at some point that the federal, I think it's like the housing assistance numbers. So they would give a list of how many houses in this tract are, within 5 years set to leave assistance, and then how many within 1 year. We didn't know if those were mutually exclusive or not. So we assumed that they were. That's a big assumption that went into this. And you can see like estimated subsidized housing percentage is kind of where those fell into. I'm not sure if that weighting would be affected if those were not mutually exclusive and what we would need to do to kind of pull them apart. But I just thought I should mention that. In fact, most of the weightings do correlate pretty highly, which is what we expected. But it was just good to kind of check that and see what happened. After we did that, we were able to, thankfully, but Jacksonville kind of fell in. Like the median around Jacksonville is roughly in kind of the bottom of the set, like what a couple of the other presenters had where Jacksonville was kind of like in the bottom 5 or something. So I think that's a good sign in general, but currently falls in using that displacement index measure. The index itself, goes from 6 to -6. That's my fault. I forgot to re-normalize afterwards to get it like between 1 and -1. But 6 is more displaced. -6 is like least displaced. And then this just shows us the index values for each tract, like how many tracts fall in to each value. So we did get normalized data, which is why we decided to click on a tract, use the regression values, and like plug in, by amount, how much you want to change each value, and see, with other values being held constant, how much you should expect the displacement index to fall or rise, and then we should ask one of the mentors. We got past the data step around like 6 or 7 p.m. yesterday, and we couldn't quite find anybody to, hey, what are we allowed to bring in here? So we just stuck with what we had. So if I had like a asterisk or like, a big regret, it's like I probably should ask for more indicators up front that we can go back and test on, because most of the ones we ended up going into the index. We had 5 left over. We put them in kind of like an all flavors at once mix. We scored a 1 for R squared, so good news, we solved the housing crisis. Obviously not, so like we had high multicollinearity between the variables. We dropped 2 of them. One of them, the census housing overcrowded housing units value, which is also obviously, they don't have a lot of control over when and how they work and things like that. Our R squared was like moderate, so about 0.34, sorry, yeah. So not high, but at the same time, we only had 3,000 units. The percentage of no vehicles, right, you would have to put 0.01 for however many percent you wanted to raise it. And so basically the estimate is something like the index shifts by about 1 in 20 for every 1% change you have in the no vehicles. So the way I kind of looked at that is if the top of the index is 6 and you gave everybody in that zone a car, they would drop down to 0. Like they would go immediately back down to the bottom, assuming that that the regression fits really well, which is kind of questionable by the first one. So then just kind of the post hoc analysis, we looked at the residuals. Most of I can't quite quote offhand like what all these are. So overall, the regression fit is good, even if the R squared isn't too high. And that's basically where we stopped. So I'll leave it at that. Any, questions?
This group name is the Maybes.
Hi everyone, my name is Anthony. I'm majoring in IT at UNF.
Hi everyone, my name is Yu Yin and I major in statistics at UNF. And we are the Maybes.
Alright, for this hackathon we chose the second problem case, and that was to build out an affordability index formula visualized clearly.
We chose this case because we believe we have the skill sets to solve this case, and we wanted to step out of our comfort zone to
based on a daily basis through a numerical fashion which would be easily understood. And to do this we utilized numerous Python packages, the IDE Spider, and for instance some of those would be MATLAB, I believe, and it was Pandas.
We also intended to use Tableau Desktop Public Edition to generate a map for.
But there are also inconsistencies with it by a category basis, as well as some null values that we encountered as we were working through this. Depending on the category, some of the null values would range up to 30 to 40%. So we would have to find a way to cut those out of the final CSV file we would use at the end. And we ended up choosing. All right. So for this project, we used 3 steps to really try to encapsulate our values that we would derive from the data. The first step would be combing through and limiting the sources by seeing which source would have too many null values to compute with even. And then the next step would be determining which sources to use through a k-means clustering method. That would really mean grouping the sources by how they would impact affordability and how they are related to each other. And so with that, we found our 3, and then the next would be or standardized, so that everything would fall in 0 to 1, fall between 0 to 1, and then we applied equal weight to each factor in the formula to over 3. Here's the elbow plot that the k-means clustering method that we used output. As you can see here, with the y-axis being inertia and the x-axis being the number of clusters, it recommended to us the optimum amount of clusters being 3 because of how the inertia dropped so harshly once it reached 3 clusters, meaning that there would be, in the clusters, there would be the least amount of variance. And for our performance results, we were able to output these were our affordability index results in a CSV file. And next we have a draft of what our dashboard would look like after inputting this.
So this is the design of our affordability index dashboard. So we will have a heat map with different color coded. So when it has a high affordability index, we will have a darker shade, and when it has like a lower affordability index, then we also provide like the sliders for the users to adjust the weights of each variables with their own preferences. Then we'll generate a result based on our formula to show the user the overall affordability index. So the higher affordability index, which means that it will be a higher possibility the people in Jacksonville will be able to afford housing. So based on the formula, when it has like a higher income, a higher inverted home value, when it has a lower inverted SNAP benefits, then we'll have a higher affordability index.
All right, to end up,
In conclusion, if we have more time, we'll sort and compare more data, and we will also bring the dashboard to life with more interactions and more features.
All right, to improve this, we would need to further test this formula and bring it to the different cities around America so that we can see if the results hold up even regardless of the differing economy and the different characteristics of the cities. But there were some risks involved with using this formula, specifically the weights. We used equal weights, meaning that we determined that each factor of our formula would have an equal impact on the final value, but that may be different. Any questions?
Good.
Shout out Dr. Dan, Mr. Karthik, Marian, and Baraka.
Coming to the solution summary, to solve this problem, we built a AI model, and the model is to measure the risk of housing displacement for every neighborhood and to compare Jacksonville's trends with 19 other US cities. We used more than 150 public data sets from sources like HUD, USDA, and My Sidewalk. And the system automatically cleans and prepares data, finds important features, and makes predictions. And on the right side, you can see the outputs and the risk description and APIs. Our data we took our data from the several sources, mainly housing and demographic data sets. We used information and then we created a label for each area based on three key indicators, based upon the percentage of low income houses. These labels help the AI learn what high risk neighborhoods look like. And about the bar chart which is present over there, that shows most of our houses. Yeah. We also use data from US Census Bureau, and which added important information about income and rent. Other smaller sources like USDA and EPA gave us extra details about environment and community factors.
So the three models we used were logistic regression, random forest, and gradient boost. So in this, random forest had the best accuracy. So our predictive AI model with 78% accuracy and balanced precision and a recall for high risk areas, both around 0.7. In simple terms, the model correctly identifies about 4 out of 5 neighborhoods that are truly at high displacement risk. This means our approach isn't just theoretical, it's reliably distinguishing stable versus vulnerable areas, giving city planners early actionable insight before displacement happens. So the random forest model uses socioeconomic and housing indicators like rent, burden, income. We focused on understanding what drives displacement risk, not just predicting where it happens. Our analysis found that the strongest early warning indicator is rent as a percentage of income, showing plus 0.68 correlation with displacement. And other critical factors include high overcrowding, no vehicle households. Based on these patterns, we identified clear early warning thresholds like rent. Whenever the rent goes more than 40% of income, that's early warning. Then the overcrowding more than 10%, then the SNAP dependence more than 15%.
As my friend said, we use the same features for the objective 2, which is to compare Jacksonville with the other major cities in America. And here are our findings. We got the top 10 cities which are in high risk in the America with a high predicted risk percentage depending upon the tracks, and Jacksonville is in the bottom 10, which is like to not 7 census tracts to get the geo IDs. And using this, we created a future map of the Jacksonville, dividing the map into different parts using the geo IDs and predicting the top 15 places of Jacksonville which are at the higher risk. We have colored the map with the darker color indicating the higher risk and lighter color indicating the lower risk. Here you can see the map of Jacksonville where south side is colored more red. So it's a kind of Bay Meadows area where more IT residents reside over there. It's marked more red, and the downtown city where outskirts of the Jacksonville are dark light. So they are having high risk, low risk compared to other parts of Jacksonville. It gives a clear insight for the investors and policymakers to invest future in Jacksonville and make decisions. At the end, we have achieved to create a predictive AI model which takes raw housing data and gives the output as the partitions where it says input to the policymakers and insights.
I just have a quick question. I'll yell it. Is there a data set? Y'all had the three, the low-income, overcrowded units, and household.
Automated way to clean and normalize the data. So you automated way to clean and normalize the data. So did you develop something that actually could take that data and automate this? So if this was to put in production, it can automatically ingest data and then deal with the missing values?
Yeah, we deal with the missing values. Like first of all, we categorize all the data and we got the ample amount of data. We got the ample amount of data. We can't run all the data on our RAM. Our RAM got we need to have data, and if there are only some kind of null values, if we can still use them, and then we fill the values with the most predicted median values, and we consider the data. Then the most considered features are like the overcrowded people in a family, and families spending 50% or more of the income on the rent, and people without vehicles in the income on the rent, and people without vehicles in the home, and expiring.
Let's discuss the finalists, and then once all of the results have been tabulated, finalists selected, then both the judges and Dr. Mapthi will come out and we'll award the winners, announce the winners and award the winners. So I will be your like MC in between during that time and try to have the students reflect a little bit, also some of the mentors and even our participants to reflect on what you saw, what was interesting to you, and what you want to know.